Hi there, I'm Professor Rafael Bonato, and I welcome you to the Food Chase first module class. I hope you enjoy this class and you take the best of it. Today, I'm going to be walking you through the slides that are based on the written document that you have access. So this is a summarizes the majority of the information that has been shared with you. I hope you enjoy the walk. The first slide will be just sharing with you our first step of our first module, which is related to the learning outcomes. And for such a class, which is the module number 1, we have defined 4 different learning outcomes as follows. Explain how KPIs inform production decisions by measuring efficiency, resource use and waste generation. We are looking at describing how processing conditions affect yield, product quality, and food waste formation. We're looking at evaluating how maintenance schedule enhance efficiency by reducing both variability and preventing equipment-related losses. And finally, as the last learning outcome, how to integrate KPIs, processing choices, and maintenance practices to assess overall production efficiency and propose waste reduction strategies. You will be noticing that the waste term will be always present during the entire 10 modules. And it's on purpose because waste is something that always happens, but we are always looking at decreasing it, okay? Let's go to our course overview. Just before that, the explanation of this slide, the centrality of efficiency in food system, which is the first chapter of our presentation. And we start with this paragraph introduction, and with this figure that shows the carbon cycle and show some of the waste cycle and the industrial cycle and how it does impact on the environment, okay? The global food system faces rising pressure from population growth, resource limits, climate change, and consumer expectations. This is a bit of what we're looking at understanding on this module, understanding how we can be more efficient and the impacts behind that. Once we understand the impacts behind that and the genesis of such impacts, we can then proceed to solving the problems, okay? And production efficiency goes beyond output. It requires reducing losses, optimizing raw materials, ensuring reliable equipment, and maintaining productive quality. This paragraph is very important because it gives us some idea of what efficiency is and what does it requires to be more and more available, more and more viable actually to our currently actions, okay? The next slide, we talk about now the KPIs, which stands for Key Performance Indicators. And this slide focuses on KPIs for sustainable food production, which is the main goal of our training. The KPIs, as a definition of terminology, provide the structure needed for evidence-based decisions in sustainable food production, turning complex operations into measurable insights that reveal inefficiencies and waste hotspots. KPIs, like the name says, is an indicator of performance. Once you're measuring and you're monitoring, you are able to decide what to do and when to do the change or when to actually act accordingly, okay? KPIs, they support evaluation of efficiency, safety, environmental performance, and reliability while enabling benchmarking across time and facilities. So KPIs, as I'm telling you here, is applicable to different levels of the processing system, different areas of the food industry, etc. It's what we call a transversal thing that works across many different steps of our production, okay? Helps us understanding what's going on, what's happening, how to act accordingly, as I said before, okay? This figure here just show you some of the cycle of what we do with the KPIs, not just for the sustainable food production, but KPIs as a whole. We normally plan, we do, we check and act. Why we have divided these in 3 or maybe 4 different steps? Because first we have the idea, we plan, we understand by the data we have in our hands. We do the planning, okay? After we planning, we actually act, like the do, okay? We're gonna do the things that we have previously planned. Once we plan, do. We checked to adapt. We checked if the results of what we have done are actually good. If they're not good, we adapt. And that's why we keep following the cycle. It's a process, it's not the end by itself. And that's why we always keep planning, doing, check, and adapt. Those two, the bottom ones, the do and the check, adapt, we always be doing this because process is changing, industry changes, and technology changes. That's why we keep the cycle, okay? The next slide, we talk about the differences between different KPIs, okay? We qualify them here as a few different ones like productivity KPIs, quality KPIs, and sustainability KPIs. They are different from themselves, and we have divided them. The literature, the methodologies, they divide them because it makes it easier for us to understand the functions of each of those KPIs. And you'll be finding more in-depth information on the written material for each of those KPIs. The main goal of this module here is just to introduce you, giving you an overview about what we are going to see on the written material, on the tests and exercises, okay? But on the figure on the right-hand side of your screen, you can see some of the quality assurance KPIs and how to communicate, how to measure, how to define the target. Because remember, you have the key performance indicator, but you need a target to where I'm going to, what I'm going to be reaching, okay? And then you define the data source, how you're going to be collecting the data to feed into indicator, and then how to report. Remember, reporting is very important because it does communicate what's going on, what the impacts of these indicators or the performance indicators on the quality, okay? The next slide, we talk about raw material processing and its impact on food waste. And we divide it from different subchapters. Here we have raw material processing food waste, and we have processing steps and patterns, okay? And you're going to be noticing that from the first subchapter, the material quality, storage conditions, and equipment calibrations and operation practices directly affect yield and product integrity, okay? And inefficiencies such as poor reception, remember the first step of your food industry, cold chain failures, incorrect settings cause spoilage, excessive trimming, and significant economic and environmental losses. Again, here we have losses, we have waste. That's why we do most of our job to avoid it or maybe decrease. Avoidance sometimes is not very feasible. It's normally not feasible, but decrease is always feasible. And that's why we are looking at watching the process and monitoring, okay? Regarding the other subchapter of processing steps and waste patterns, here are some of the steps that you normally follow when you receive a food, example of fruit from your food industry. Cutting, mixing, heating, fermenting, each produce specific waste patterns driven by blade conditions, process control, and raw material variability. As I said before, these are all in-depth explored in the written material, and the exercise actually will help you understanding and fixing such a knowledge, okay? Just stepping to the next slide, we have the chapter of our first module. You will see the relation between the presentation and the written material, and you'll be able to following up both insides, okay? This slide is relevant to the determinants of raw material efficiency subchapter. And we divided here again in two subchapters, the processing techniques and waste profiles, as well as determinants of raw material efficiency. We're going to see on the processing techniques and waste profiles that each processing steps generates distinct waste patterns influenced by blade conditions, operator skill, and material variability. We see that the poor protocol in mixing or grinding leads to defects on batch rejection. Sometimes you're noticing by reading it and studying that sometimes the very little things we do at the beginning of a process actually define and act as determinants of our raw material efficiency. And we are not looking at the highest technology ever. We're just looking at following up the protocols, following up the process to understand where to act and to improve, okay? Just jumping into the second subchapter, determinants of raw material efficiency. We see that reception conditions determine usable yield, like I said before, the first step of reception. Low quality or inconsistent material increase streaming and waste. Storage or cold chain failures accelerate spoilage. This is very key to understand. Incorrect equipment settings create defects and losses, and efficiency relies on good material quality and stable storage and proper calibration. Again, sorry, here is a figure that shows what we call the food circular economy before retail and consumption. You see that this figure shows the cycle of what happens before I actually put my food, my fruit or vegetable into the store itself. Explain what's happening, what happens, and the relations connected to each other. This is a very figure. Always remember that for each of the figure, there is a source of where I have collected. So you can click on the source, access the article, and read more in depth. Okay. The next slide goes about processing techniques and waste profiles, as well as smart technologies in processing. Okay. This is smart technologies in food processing. We're looking at, they exist, they've been drafted to improve precision, reduce variability, and enable continuous monitoring. Optical sorters is an example. Remove defective materials early, preventing downstream quality issues. You see that technologies, they help us having a better process, they help us decrease the waste, but they never substitute our reception at the beginning of our process. They all exist to help us during the process. Okay, they will not save the batch, but they'll help us improve a lot. Okay, real-time sensors adjust moisture, temperature, and other parameters to maintain safety and consistency. Automated portioning ensures accurate fill weights, reduce losses and consumer complaints. You see that if you're selling a package that says 500 grams and you're actually delivering 450 grams, you're having a problem on accurate fill weights. That we actually increase the customer complaints. So by having those technologies, you're able to avoid these things. They actually work as predictive models that anticipate quality deviations, allowing proactive interventions. This is a real example. And effectiveness depends on proper calibration. Machinery is always calibration, strong maintenance, and skilled operators who can interpret data and ensure process stability. We're going to be focusing on those two very last subjects more on the next classes, but you see that calibration, maintenance, and operator training are key as well to the process. Okay. Maintenance schedules and their influence on efficiency. Let's start with this figure on your right-hand side. This is what we call a preventive maintenance. You see that we have a few different subclasses of maintenance, preventive and predictive. I explain soon. But this figure here relates to preventive maintenance that is composed with those 7 different steps that you'll be able to read and understand more in depth. Okay? Just to quickly explain you the difference between preventive and predictive maintenance. Preventive maintenance uses scheduled actions to avoid breakdowns and keep equipment reliable. Okay? Predictive maintenance applies data-driven tools to detect early signs of failure and intervene only when needed. Okay? This is what we call corrective maintenance occurs after equipment failure, causing costly downtime, material losses, and safety risks. You see that the corrective maintenance only happens because a problem happened before. And this is the main difference between preventive and predictive. Okay? And the last bullet point explains modern system prioritize preventive and predictive approaches to improve efficiency, reduce disruptions, and minimize waste. Understand here, reduce disruption as reduce stopping your line of production. Okay? This is the main thing here. The next slide is about the maintenance schedules and their influence on efficiency and the effects of maintenance on food waste. A proper maintenance directly reduces food waste by preventing, remember, preventive, equipment-related inefficiencies. Misaligned cutters in inaccurate weighting system causes excessive trimming and overfilling, increasing raw material losses. You see that you have a packet of 500 grams. You're actually filling it with 450 or maybe 550, 50 less or 50 more. You're running out of your planning schedule. You're running out of what you have already planned. So these increase raw material losses. You're not looking at losing things. You're not looking at producing more waste. Other point, important. Temperature deviations in heating, cooling, or storage create safety risks and can force entire batch to be discarded. This is a scenario that you are not looking at. The figure on the bottom left talks about explain the source of food waste and share of total. You see here is a very interesting number. 21% of the losses of the food waste occurs within the farms. And then once we have received these on our food industry, happens that 14% on the manufacturing, exactly where we act here, and we are focused on a food chain module, okay? Food retail, another 12%, food services, another 16%, and homes, 37%. This is a lot of waste. That's why we must start it on farm and then work our way out to the manufacturing, and after manufacturing work with conscientization of our public, both the food service people, the retailers, and the homes. So you see that our work does not stop here. It just actually begins here, okay? And other example of efficiency, mechanical failures, leaks, ruptures, contamination, damage product integrity, and require immediate disposal of affected material as a consequence. Unexpected downtime interrupts process and often results in incomplete, unrecoverable products. For example, if you have a food that must be boiled to a certain temperature and you actually overpass such a temperature, you cannot recover it. You have it wasted. You cannot return to the process and use another line. It's waste. Okay, that's why unexpected downtime interrupts and influence negatively a lot of the food industry process. Okay, and effective maintenance is essential for waste prevention, product quality, and sustainable production management. Well understood. Regarding the chapter of maintenance schedules still and their influence on efficiency, we explore here the integrating maintenance with the KPIs. And if we start with the figure on the right-hand side, we have an example of the maintenance connection, the 8 principles of maintenance KPIs to track, which we'll be able to follow and we explore over the time of our presentation. But mainly, the idea is pass you the knowledge that by integrating maintenance data with the KPIs, links equipment condition to production outcomes. You see that? You have the maintenance data. That example, I must check the oil levels of my machinery on every fortnightly. If we do integrate such a data with the key performance indicators, we have something work very accordingly, very, very balanced, okay? Synchronized, maybe. Indicators such as MTBF and MTTR, preventive maintenance and completion rates, and schedule versus unscheduled downtime, reveal system stability and responsiveness. When combined with production KPIs, these metrics provide a holistic view of reliability, efficiency, and waste risk. This integrated approach helps identify vulnerabilities, prioritize interventions, and align maintenance with broader efficiency and sustainability goals. Very key. Explore it on the written material. You can see, you can understand that those knowledges are very important, both MTBF and MTTR, and will help you understanding the entire cycle, what's happening and what's not happening, how you as a technician, how you as an owner of a food industry or food factory itself can act accordingly. You have a notice on this module that when we understand what means the key performance indicators and how to use them on our daily activities, maybe if you can, connecting them, integrating them with the maintenance data, you'll be able to work and understanding the problems and the perils of your system from the beginning of the food reception to the delivery at the retail or the shoppings. You see that? KPIs help you in all the stages of your food production. Like I said, if you can apply a KPI on the reception of your product at the door of your food industry. And you can apply, maybe if you have a time, interest as well, to apply those KPIs to the consumer, the final consumer, to understand if he or she is accepting well, if the market's actually receiving well your product. You'll be able to integrate data with the KPIs and take the best of it, understanding how to act. Sometimes it does not cost more, it actually costs less because you're working with more efficiency. Okay, I hope you have enjoyed this first introduction to our first module of a food chase training, and feel free to drop me a message to clarify any of these questions. And remember, all the things that I have touched here, slightly quickly touched, are all more in depth into the written material that you can access at any time. Thank you for your attention and have a great time.